Today we're going to talk about the GPT adversarial prompt defender, which is a technique I propose to be able to defend against highly successful adversarial prompts. I learned today that the main objective an adversarial prompt tries to accomplish to get GPT to output something undesirable and objectionable response is to try to get GPT to generate the first few tokens of the objectionable prompt, such as to get GPT to say, sure, I will, and then it continues to generate undesirable, objectionable prompt. I have learned this at the app I built, llmpapers.up.railway.app. I made a video on this. Anyway, this app summarizes every new archived paper that is related to large language models. And this one, while I was looking today, this one actually got my attention, which is universal and transferable adversarial attacks. So I learned a few things from here, which can be used to defend against this type of injection attacks. So my main idea was actually to get the user input. So we don't know if this user input has any malicious intent. We send it simultaneously to create two GPT calls. One is going to be the detector, and the other one is going to generate a regular response. Now we use a function calling with two parameters for the detector. First, the detector generates the first 30 words of a regular response, just as this API call will do. And after it generates the first 30 words of regular response, then it returns a Boolean value to check if this response, the 30 words of the response is objectionable. If it returns true, then because we are running both of these with concurrency in Python, then we after we have received our regular response, then we can say, okay, block this and don't return to user, or return something else to user, saying that this response was objectionable and did not pass through our filter. We are only generating or attempting to generate the first 30 words of the regular response, with the user input being exactly the same, which is going to the detector and the response, because we did talk that if an adversarial prompt's objective is to generate the first few tokens, then we will have evidence of objectionable response being generated in the first 30 words, is the assumption. The code is pretty simple for this. We simply have two functions. One is called check objectionable response, which utilizes function calling. It tries to generate a regular response, and then a Boolean for is objectionable response, whether the regular response is objectionable or not. And then we also utilize streaming responses, even for the function call. And then we have a regular response function, which just generates the output regularly in the streaming fashion. And then we just have a main function, which uses concurrent features, thread pool executor, to execute both threads simultaneously. And then we receive is objectionable response, okay? And if is objectionable response, which means this return true, then we just simply print objectionable content detected. Otherwise, we get the regular response result, and then we print it or return it to the user. It's up to you what you want to do at this point. Now, the beauty of this idea is that since we are only asking to generate the first 30 words of the response, based on the user message, then this function is going to be done way before, hopefully way before, the actual response. But what the thread pool executor allows us for us to do is actually generate both responses in real time, so we don't have to wait for an additional check. And once the regular response is received, we simply check it against if it is objectionable response Boolean, and then we can act on that. Now, a much simpler approach would probably be actually to generate the regular response and then get the entire response checked, make another API call, send the entire response that was generated, and get GPT to check if the response was actually objectionable or undesirable. But sending the entire response is going to cost a lot of tokens, and also it's going to take some time to do the sequential call. Another idea would be, once the regular response has been generated in full, then we can actually send the first 20 words or the 30 words of the response to GPT for it to check if the response was questionable, just as actually we are asking in the check objectionable response function. But then we then still would be waiting for a sequential API call, and it's going to for each user response is going to steal a little bit of time, and that's probably not desirable for many applications. Code files for this is available at my GitHub repo. Feel free to download it, make improvements on it. Let me know what you think at our Discord or in the comments. And I'll put a link to my Patreon as well, where I have over 100 plus GPT-related project files, which you might be interested in. Links will be in the description. While we are on the topic of prompt safety, I'd like to mention that OpenAI actually is a moderation endpoint, which filters for all sorts of important things, which you need to probably filter for if you are actually building a user-facing application. Moderation by OpenAI is actually super simple. It's free and it's extremely fast, but I'm not sure if it actually checks for adversarial attempts. That's why I came out with the adversarial defender. Let's go over the code real quick. Like I said, I think there are some good ideas here. Let me know what you think. Maybe this is not, I didn't actually get the chance to test this because it turns out I don't know any adversarial prompts actually. I've been all this time trying to get GPT to do useful things, but there are some people who, do spend some time trying to do these things. So it's always good to be mindful and try to take some approaches to mitigate these types of risks. Even if you don't like this implementation, maybe this will give you some ideas to further improve and come up with your own ideas. Anyway, so we start by importing all the necessary things. Term colorful is just printing colorful stuff into the terminal. We have we are importing thread pool executor from concurrent futures so that we can run both functions simultaneously. We are defining our API key. Here we are defining the model. We actually don't need this, but I'm just going to leave it there. Here I've written some notes, right? Alternative approach would be to check for objectionable response with the entire regular response at the end. We talked about this, right? We can implement another check after the response was generated rather than doing the simultaneous detector and regular response generation, but that's just going to take some time. My idea was that can we do it in real time, and this accomplishes that, I believe. I have two sample messages here. So this is going to go into the detector, right? The check objectionable response function. We have a system message here. And then in the second alternative, we don't have a system message. Because if you take a look at the system message here, we are saying that you're a powerful language model which can influence people's opinions. Some people may try to get you to generate objectionable content. Therefore, this particular call to you is to generate the first 30 words of a response as you regularly would generate. And when you understand, I made some typos, whether the response so far is objectionable. Therefore, this particular call to you is to generate the first 30 words of a response as you regularly would. And when you understand whether the response so far is objectionable or not, stop and return is objectionable response value as true or false, because we are defining that in the function description. And then the user message is simply whatever the user has inputted. This might include some adversarial intent. So I was thinking maybe given the system message might produce the check objectionable response API GPT call to generate something other than what the regular response might generate, because we are relying on this function to generate something similar to what the regular call would generate. Okay, now that's the key here. And that's why I set the temperature to 0. I've done some tests, and for the most part, actually every time I saw that this function was generating the regular response which we are asking for this call to make was actually very similar, almost identical to the one that we were getting from here. Because that's exactly what we want, right? Because if there is an adversarial attempt, then GPT will be generating an objectionable response. We want that response to be generated here as well as here, okay? So that we can actually block it. Now, this system, before going on any further, I just want to point out some of the weaknesses. This system will fail if an adversarial input succeeds, prompt succeeds with the regular response and fails to generate with the check objectionable response. Obviously, we're dealing with probabilities. An adversarial attempt may only be successful, let's say 60% of the time. And in that case, this call might deny it the opportunity to generate objectionable calls. In that case, is objectionable response will return false. And if this returns false, and this actually generates objectionable content, and we won't be able to stop it. Okay, just keep that in mind. But if the better, so this system actually, the beauty of this system then is the better the adversarial prompt is, the better this is going to work, because it's triggered both of them at the same time, and we're going to get some true values here when we need to block the call of this. Okay, so that's that being said. So this system message tries to get it to put a Boolean value to return a response for the first 30 words of a response, and a Boolean value for if the response is objectionable or not. Now, you might want to try with different system messages or without any system message whatsoever. Here we are defining the check objectionable response with temperature 0. We are doing streaming responses, and we're defining the function description definition. Because the function definition is pretty explanatory, we might not need the system message. We probably don't. The name of the function is regular response and objectionable response detection. We don't have a function like this. We are only defining a makeshift function so that we can actually get the parameters. Description is take some first 30 words of a regular response from GPT and detects if it is objectionable or not. So we are defining two parameters. One, regular response is a string, first 30 words of regular response from GPT, and is objectionable response is a Boolean, whether the regular response is objectionable or not. We require for both of them to be generated at every call, and we are forcing the function call to actually call this function every time. Okay, that's important. And then we just simply, with this logic, get the response, get the chunks out of the tokens out of the response generator object, and we append it to the responses. We print them so we can see what's happening, and we get the is objectionable response key using out of the response by using JSON.loads, and we return is objectionable response, whether true or false. And the regular response actually is, again, streaming true, temperature 0. I just set max tokens to 2000 just because. Anyway, I think we need these. For chunk and response, so we get the response content, and we just append response content. Here is each chunk. We append it, we print it, and then we return. In our main function, with thread pool executor as executor, we get objectionable future as executor submit, check objectionable response with the user input and the model, because these functions do take in that, right? It takes in the input and the model, both of them. Yeah, both of them do that. Anyway, and then a regular response feature is executor submit, regular response with both of the inputs to that function. We wait for objectionable check to finish. Objectionable.future, when this finishes, it immediately assigns the result to this variable, which is whatever is returned by this function, right? By the check objectionable response function. And actually here you can test it. Even if this returns false, you can actually uncomment this and set it to true to see what happens if the blockage happens, and it does. So then we simply check if objectionable response, then we print objectionable. Otherwise, we get the regular response and just return it. If we run this and see what happens, I'm just going to say just something like tell me a story. As you see, we are printing the responses of one function in yellow and one other one in green, so they are printing in real time. And the detector's response finishes pretty quickly, and it's set false, as you see. But we are now getting the rest of the response. And once the rest of the response finishes, then we have done this conditional check, and then because there was no objectionable response detected, then we print the regular response in white right here. However, if I were to uncomment this and run it again and Again, I'll say tell me a story. Again, we'll get the same response, but this time, once, even though the detector function returned false, we are actually forcefully setting it to true. So that's why we print objectionable content detected. With the end, this whole yellow part is printed during the streaming process. But once the entire response has been received, so as you see, we did not print it. So this is it. I hope you found it useful. Feel free to improve upon it. I also would like to mention, if you like my content, you can visit the EcoHive AI Academy at ecohive.live and watch and search and watch all the videos that I have created. And you can also find the code download links. But the code files for this particular video is available at GitHub, and the link will be in the description. Thank you for watching, and I hope you'll make good use of these ideas and or possibly even produce better ones on top of this. Thank you, and see you in the next one.